Hello, students. It's 5.8. It's the last one of Chapter 5 before, of course, the practice test and the test. But this is it, fun. Chapter 5 is almost over. Woo, yes. Now, at first glance, this looks pretty difficult, but we're going to make rational inequalities. Now, by now, you know that rational is a math teacher's term for fractions. And everybody loves a little bit of fractions. A little bit of fractions. Here I am. Anyway, we're going to solve some rational inequalities. By the way, all of these videos can be nicely found at www.nkinfinity.com. It's from my partner, Miss Newman. I'm Mr. Krause, but you're going to call me Mr. Key for today because I'm going to help you answer all of your questions. Of course, I'm going to drink a little bit of coffee while I do it because it's, oh my gosh, it's 6 a.m. It's like late. Oops, missed the question. So here's the question. Seems pretty simple to start with. Let's solve this inequality. What? What do you mean solve that inequality? Are you crazy, Krause? All right, it's not that bad. Here's your first step. It's like simple steps. Here's what we're going to do. First thing we're going to do, factor. That's step uno. I hate saying steps because, you know, you get quadratics. You get some things like, let's just factor this thing. So we got this. Factor the numerator. All I did was take out a GCF. Factor the denominator, which really didn't need any factoring. Then this is number 2. This is the important one. This is like the creme de la creme. If you screw up this step, you're messed up. Really what you need to do is find these things called critical values. Critical values are what make the top or bottom. Top or bottom. We know those as the numerator and denominator equal to 0. So what makes the top or bottom, if you're like in 3rd grade, or let's jump up to like 11th or high school and say, okay, numerator and denominator equal to 0. What value makes them equal to 0? So all you do is set them equal to 0. It's kind of like when I almost said the F word. Clearly when you almost say the F word, you don't have enough coffee in you. This, by the way, is my first cup, so if I seem a little bit down and all out craziness, it's because I haven't had enough coffee and my glasses are really dirty. So, here's what we got going on. We need to figure out what makes these things equal to 0. It's kind of like when we're trying to determine when a function or a rational fraction, is undefined. When is it undefined? Or when an irrational equation is undefined, we set the denominator equal to 0, but now we're going to set the numerator and denominator equal to 0. So I quickly set those equal to 0. I get 2 critical values. Now you're going to see why those are critical values in just a second. I will probably put these on the calculator. We're going to end up using a calculator later, but here's what it looks like if you graph it on a calculator. So if you graph it on a calculator, you have to, first of all, make sure that you can see your critical values. If your critical value is like 8 or 9, you'd be able to see it. This one goes up to 10. The default for it is this 6.7 and negative 6.7, but you need to be able to see the critical values, and you need to be able to see the graph, see what's going on in the graph. So sometimes you're going to have to change those numbers. We'll talk about changing those numbers as well. And what we want to determine, just as I've talked about in class, is where is this thing going to be positive or negative, and identify it. And again, we've talked about this. When the y value is above the x-axis, like it is here and here, we have positive. When the y values are below the x-axis, like we have here, then it is negative. Now, I could do this. I don't need a graphing utility to do this. I don't need it. I could just say, okay, like I got here on this number line, I could say my critical numbers are 1/2 and 2, just like I have on this number line right here. And I could just substitute certain values into that equation. For example, let me substitute in what's to the left of 1/2. I could substitute in 0. So if I plugged in 0 into this equation, plug in a 0 and plug in a 0, the numerator is 2 times -1 all over 0, 0 minus 2 is just -2. So that's -2 over -2, and a negative divided by a negative is positive. So every value to the left there will be positive. Then I can come through and say, okay, we're going to try a value in between. Like, for example, we'll try 1 is in between. So let's try 1. We'll put a 1 in here, and I'll put a 1 in here. In the numerator, you get 2 times, this is 2 minus 1, which is 1, all over 1 minus 2. So that becomes 2 over -2, but, 2 over -1. But more importantly, I don't really care about what the numbers are. I care about it's 2 positive over negative, and that makes this area negative. And finally, I could plug in some number to the right. Now I can try to pick in, if I can't plug in 0 and I can't plug in 1, I'll try to plug in like a 10. So if I put a 10 in here, clearly the top's going to be positive. If I put a 10 in here, clearly the bottom's going to be positive. And a positive divided by a positive is also positive. So this area would be positive. So clearly, I don't really necessarily need the graphing calculator, but it sure as heck does help. It's very simple to see where those y values are positive. And finally, we need to write the equation. We need to write our solution. Well, we have to remember that, just like I said here, greater than 0 really means positive. Greater than 0 means positive. So we want these areas that is positive, going to the right and going to the left. So that's why you see that I shaded those answers. And the final thing is to state your answer. Interval notation is always a good one. You could have, because it didn't specify, you could have said, oh, x is less than -1/2. That's what this piece means. Or x is greater than 2. But we usually default to interval notation. All right, so let's get ready to start. We're going to start these, and we're gonna find out that they're not too bad. I just listened to my voice, and I sound like I'm sick. So I'm hoping I'm not getting sick, because everybody at school is getting sick. But I hope I'm not getting sick. All right, here we go. We're going to solve them, state the solution. Solve and state. So. First rule, rule number 1, identify. Well, actually, the first rule is to factor, right? But I don't have to factor. So now all I want to do is, now that I have 5 over x minus 2, I want to identify my critical values. Now, my critical values are what make the numerator equal to 0 or make the denominator equal to 0. Since I can't make this equal to 0, I don't even care about that right now. The only thing I want to do is what would make my denominator equal to 0. In this case, it's x equals 2. So that's my one critical value. Now I want to graph it. So I am going to put my number line here. 2. Now I'm going to show you we can do this without using a graphing calculator. So if you're at home and you don't have one with you, or you don't have one handy, or you just would rather not do it that way, we're going to plug a value in. So this is kind of like our breaking point. This is our cutoff point. We're going to 2. So we're going to pick a value to the left. I'll pick x equals 0. And we'll pick a value equal to the right. And I'll say x equals 10. So if I go back up to the original equation and I say, okay, I'm going to plug in a 0. So it's 5 over 0 minus 2. Is that less than 0? Well, that's 5 over negative 2. That's a negative. So on this side, it's negative. If I plug in 10, it's 5 over 10 minus 2. That's 5 over 8. That's positive. And the only thing we care about is positive or negative. In this particular case, I don't know why I just did that. In this particular case, we are looking for less than 0. Now, you have to understand that means negative. We are looking for the negative spot. So that means it would be an open circle because it did not have an equal to, and we want the negative. We want to point toward this way. Now let's look at it graphically. going to look at this thing graphically. Hopefully we're going to look at this thing graphically. And it's a fraction, control division, 5 over, okay, somehow we missed the 5, 5 over x minus 2. Enter. All right. So the cutoff here is x equals 2. Now, some of you can't do this on your calculator. I think I can do this. Yeah, there's the line x equals 2. That's the cutoff. Notice it's now you can see that we have a vertical asymptote here at this x equals 2. And if I pull in closer, you'll see that the line just keeps getting closer and closer to that. But notice when I'm to the left of this line, I'm below the axis, or negative over here. And when I go to the right of this, I'm above the x-axis, or positive. So that's our breakoff point. And we, again, you have to remember, you have to remember that here we wanted negative. All right. So now I just got to state my solution. And if we do it in interval notation, it's very easy. Negative infinity up to 2, but not including 2. First step is to factor. Lucky for me, I don't have to. I have it's already factored. So what would make the numerator equal to 0? So 5 is a critical number. What would make the denominator equal to 0? X equals negative 3 is a critical number. So those are my critical values. If I want it on the number line, negative 3 and 5. So this breaks it up into 3 zones. You see, I have a zone here that'll be positive or negative. I have a zone here that will be positive or negative. And I have a zone here that will be positive or negative. So again, and what am I looking for? I'm looking for greater than 0. I am looking for greater than 0, so I'm looking for positive. So again, I will show you one more time that I don't have to use the calculator. I'm going to use x equals negative 10, x equals 0, and x equals positive 10. Because positive 10's over here somewhere, negative 10's over here somewhere, and 0's right in the middle. So off to the side here, let's do this. It's x minus 5 over x plus 3. So it's x minus 5 over x minus 3. So if I plug in a negative 10, so it's negative 10 minus 5, negative 10 minus 3. That's negative over negative, which is positive. If I plug in 0, 0. No, let's plug in 0. Let's see what we get with 0. Let's see what we get with 0. 0 minus 5 and 0 minus 3, that's also negative. Okay. Oh, wait, that's negative over negative, which is positive. Something's a little bit off. And let's plug in 10. 10 minus 5 over 10 minus 3, that's positive over positive, which would be positive. And I want positive. It looks like it's positive everywhere. That doesn't even make any sense to me. Something's not right. Something I did was not right. Well, we're going to go look at this thing graphically and see if I can find my mistake. This is why graphing tools are so important, because sometimes you can have a brain fart like I'm having and just go graph it and see what you see what you come up with. So we're going to go control division, and it's x plus x minus 5. Oh, that's the problem. I just found my mistake. It's x minus 5. It's x plus 3. Enter. So, let's take a look at this. Let's go back here. This should have been a plus 3. So, if I do negative, that would be negative over negative. This would be negative over positive, which is negative. And then this is positive. So, this was positive. this was negative, and this was positive. So it looks like I want these. Let's see if that's what it looks like graphically. Let's see if at -3 it's above the x-axis, but between -3 and 5 it's below the x-axis. Let's go take a look at that graph. Again, I don't think you guys can do this unless you have the new operating system. If you have the new operating system, you can do this. You can just type in x equals -3. But I'm going to show it to you just so you can see it. So there's my asymptote. And it looks like for here, it's all positive, 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 positive. But as soon as I get to -3, it's negative, 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 until I get to right here. 1, 2, 3, 4, 5. At 5, you'll notice it comes back above the x-axis and becomes positive. And so I want where it's positive. I want over here, and I want on the right side over here. So we got it. Found my mistake, which was great. Found my mistake. As soon as I was typing it in, I found my mistake. And now I need to write my answer. Well, that means my answer is from -infinity up to -3, union 5 to infinity. All right. Here's our next problem, but I'm going to go save this and I'll be right back. Okay, let's do one more example. Now we have to factor. So now we have a little bit of work to do. So what we're going to do is we're going to factor the numerator. The denominator is easy. It's already factored for us. It's x minus 3 less than 0. So while I'm here, I might write down, we're looking for negatives, right? Because that's what less than 0 means. We're going to factor this numerator into the product of two binomials. There really is only one way to multiply to 2 using integers, and that would be -1 and -2, because they have to add up to -3. So identify our, in this case, 3 critical values. Our 3 critical values are x minus 1 equals 0, so that's going to give us x equals 1. X minus 2 equals 0, that gives us x equals 2. And x minus 3 equals 0, and that's x equals 3. So this would be a very difficult one to plug numbers into, because I'd have to plug numbers in like 1.5 and 2.5. Not impossible. As a matter of fact, you know, I'm going to do it a little bit here for you. So for those of you that are smart with it students that don't always like to rely on the calculator, here's 0, here's 1, here's 2, and here's 3. So how many different zones do I have? I have 3 zones. I have this zone 1, I have this zone 2, 3. Actually, I have 4 zones. I apologize. And I have this zone. So if I tried 0, if I plugged in 0 into each of these equations, 0, 0, and 0, that would be negative and negative, so it would be positive on top and negative on bottom. It looks like that would be negative. And if I tried 10 on top, 10 and 10 and 10, they would all be positive. So positive, 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 that would be positive. And generally, they're going to alternate back and forth, positive, negative, positive, negative. So my guess is this is positive, and my guess is this is negative. And if you had to guess, that's what I would guess. But it doesn't always happen that way, and I think we actually have one on our quiz or test someday that doesn't, so be aware of that. So let me try 1.5. It really comes into play when you have squares. Let me try 1.5, which is between 1 and 2. So this would be positive, this would be negative, and this would be negative. So positive, no, this would be positive, this would be positive, this would be negative. So positive times positive is positive over negative, which is negative. Oh, wait, no, this isn't positive, this is negative. I knew it was supposed to be. So, because 1.5 minus 2 is, so you see where it's a little bit tricky, only when your brain's not functioning properly. But 1.5, that makes this positive. 1.5 minus 2, that makes this negative, and this is also negative. So the numerator is negative, the denominator is negative, and it's positive. All right, enough of that. This is what they are, but we are going to take a look at it graphically. So we'll get rid of this and get rid of this. And so what is it? I'm going to type in the original, by the way, not my factored one, because I might have made a mistake factoring, and I don't want to use the factored one because it's really bad when you graph a mistake. And then x minus 3. X minus 3. Woo! Crazy. That is one crazy looking thing. So, if I look at this right here, I'm going to zoom this in. So there's 1 and there's 2. Because our critical numbers are 1, 2, and 3. So 1 and 2. Between 1 and 2, it's positive. See how that's a little bit positive right there? Less than 1, negative. After 2, negative. So between 2 and 3. And then when I get to 3, where is it? There it is. When I get to 3, it looks positive. Now, just because I want to show it to you, because it's going to become important when I do the next problem, which I'm going to change slightly. Tab, delete. Delete 6, x equals 3. Notice that's an asymptote, and we're not ever touching it, so I can't use it, but that's my 3. So after 3, if you want to, you can plug in all these values. You can hit tab, and you can type in x, tab, x equals 1. Tab x equals 2. Those are all your critical breaking points. And you can see, you can see, I hope, that in between the red and the black, it's positive. In between the black and the blue, it's negative. And over to the right, it's positive. Over to the left, it's negative. So we want where it is, in this case, negative. So we want to the left of 1 and between 2 and 3. So we want to the left of 1 and between 2 and 3. So anytime it's two separate places, that's an OR. So we're going to do negative infinity up to 1, but not including it, union 2 to 3, but not including those as well. Now the next problem I'm going to change slightly, so I really want you to pay attention on this next one. I'm going to make one change on this problem. Not sure if Mrs. Newman is going to do it in class or Mrs. Acker is going to do it in class either, but I'm going to make this one change. And I don't know if your teacher would do this either. Maybe if they watch this video ahead of time, they'll do it, but I don't know. I'm going to make this one change, and it's going to make the problem a wee bit harder. And that is, I'm going to put this equal to here. Now, this equal to is going to cause us grief. So I want in the future, if you see an equal to know that it's causing you grief. It's a problem. And you're probably sitting there going, just fill in the circles, Krause. Yeah, sort of. We'll see. Check it out. First rule, factor it. So let's factor this baby. I almost swore again. I don't even know why. Less than or equal to 0. By the way, I'm going to write down negative again because I know I'm looking for negative. Denominator, factor that, x minus 1. That's simple. All right, two numbers that multiply to negative 8 that add up to negative 2. Well, x and x, 4 and 2. 4 times 2 is 8, and when you subtract those, you do get 2, but we got to make sure the larger one is negative. So now we're going to just write our three critical numbers. By the way, at this point, I don't need to see the work. You know our critical numbers. Here is going to be 4. Here is going to be negative 2, and here is going to be 1. But I do want you to write, hey, Krause, the critical values are x equals 4, x equals negative 2, and x equals 1. Now, I'm just going to use the graphing tool for this today, for this one today, on this problem. But if you'd like to just do the number line, that's cool too. So we're going to graph these things on the number line. Let's see, -2 would be over here. By the way, if you just put them in order, 4, -2, 1, that would be really dumb. They have to be in the order that actual numbers come in. And you should have a little bit of separation in between them, you know, that's appropriate to the distance between them. In this case, it's the same. So again, we've got 4 areas. We got this area, we got between, we got here, and we got over to that direction. So I'm going to probably pick 2. It's probably going to alternate positive, negative, positive, negative, positive, negative, positive, negative. But let's just see. So go to our graphing tool. And there's a reason I'm using this tool. Mostly because I'm a tool. Just kidding. Control division. Again, don't use your factored form of it. Do what the original is, just in case you made a mistake. X squared minus 2x minus 8 all over, what is it, x minus 1. X minus 1. Enter. Ooh, that's not kind of what I was looking for, but let's see. Okay, so we had some critical numbers. Our critical numbers were, our first one was -2. So what's happening to the left of -2? Here's -2, and to the left it's down below, and below means it's going to be negative. So down here is negative. So I know this area is negative. Now if I'm a betting man, this is positive, this is positive, this is negative, and this is positive. But I'm not sure, so I'm going to go check. So after this, it's positive, 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 positive. And I really can't see 1. Oops. Looks like it's getting closer and closer to 1. So if I drew in the line, I'm going to draw in that line. I think that line 1 is kind of important. So let's draw in that line 1. You know what? I don't like these graphs. So I'm going to change this really quickly. Here's how you change the scale. I want to make this 20. Tab. 10's fine. That's 12's fine. Tab. I want more down here, so let's go -10. Tab, and then that's fine. -8's fine. That's fine. Tab. All right, here we go. So we got them. So, but I also want to graph this line y equals 1, and that's why this problem's a little bit more important. So I'm going to tab, I'm going to get rid of this, I'm going to type in a relation. The relation is x equals 2. Notice it's a relation, not a function. X equals 1. And again, that's an asymptote. That's an asymptote. Notice the line is approaching and approaching and approaching, and as soon as I get to it, I bop up down here. So from -2 to 1, it is in fact above, so that's positive, so that we did confirm that. And from on the right side of -1 all the way up till and including 4, it's negative, so we did confirm that. And then after 4, it's positive, so we did confirm that. So now what I want to do is I want to state, or I want to graph my solution. Again, we wanted negative. We said earlier we want negative. So it's negative starting here and going in this direction. And it's negative in between here and here. And then you're like, all right, but it did say, oh wait, we changed it to cause some grief. You're like, grief? Oh, that wasn't grief. All you have to do, Krause, is very simply do this. Right? Because that's what makes it equal to 0. But one of those is a problem. And that's why I wanted to make sure I addressed it on this one. Let's go to our calculator and see what happens when we type in -2, and let's see what happens when we type in -1. So I'm going to go over to my calculator, and I'm going to store in, I'll do 4, control var x. I'm going to store 4 into x, and I'm going to type in control division x squared minus 2x minus 8 over x minus 1. Now, when I typed in 4, and I type this in, I should get 0 because it's equal to 0. There it is. It's equal to 0. That's why it's a critical value. What makes it equal to 0? If I type in -2 for x, -2, control var x, enter, and I type in this line, again, enter, I should get 0. And then my other one is 1, so control var x1, that was our other critical value, and I come up here and I click on this and I click enter and it should be equal to 0. It's undefined. It's undefined there. Wait a second, that's weird. It's undefined. Oh, wait a second. If I plug in 1 into this denominator, what happens? It makes the denominator equal to 0. So although the problem said equal to 0, you can't, and you want to fill those dots in, you can't fill them all in. I can only fill in the -2 and the 4. This one, because it makes it undefined. And now that's why I wanted to talk about it graphically. Graphically, it will always be undefined at these asymptotes, these vertical asymptotes. When we talked about that in class, these vertical asymptotes are what make it undefined. So when I'm writing my answer, I'm going to write, negative infinity to -2, including -2, union 1 to 4, including 4, but not including 4. And that's the only change, is that whatever makes the denominator undefined is you just have to make sure you can't use that in your solutions. All right, that's it. Okay. So this one is you try. You try. Now, I'm going to go through these in a second very quickly, but I want you to change these two answers down here, and I want both of these to have an equal to on them. Okay, I don't know if your teacher's going to do it, and you know now that the only time it's going to come into play is that final time. Do you fill in the circles or do you not fill in the circles? But you need to make that decision. So go through, and if you want to do one at a time just to make sure you have it right, do one, watch the video, check it. Do one, watch the video, check it. Do one, watch the video, and check it. But don't just sit here and watch me perform like a trained monkey. I'm not your trained monkey, okay? I want you to just try it on your own, right? You know those little monkeys that, start ring, the monkey goes around and around, takes money out of people's pockets. Yeah, I'm not that guy. Or I'm not that monkey. So hit the pause button, try the problem, just scrub to the end of the problem, see if you got it right. If you got it right, go to the next one. Okay, if you didn't get it right, see if you can find your mistake. This isn't that difficult, all right, kids? All right, pause. Yeah, I'm back. Yes, okay, critical numbers. Well, I didn't have to factor. You didn't have to factor. So my critical values are x equals -6 and x equals -1. I'm also looking for positive. I want to indicate that. I want to look for positive. So I'm going to graph it on the number line. And I believe we had -6. And the other one was -1. All right, so again, I have 3 zones. I have this zone, I have the zone here in the middle, and I have the zone here on the right. If you picked a big negative number, that would be like a negative a million. That'd be negative over negative. That would be positive. If you pick a number in between, like -2, the numerator would be positive, the denominator would be negative, that'd be negative, and this would be positive. Graphically, what does it look like? Let's see what it looks like graphically. Control division. What is that? X plus 6. X plus 6 over X plus 1. Enter. And that makes sense. To the left of -6, it was positive. After -6, it's negative. When I get to -1 up here, it's positive, 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 and it looks like it stays positive forever. Okay, so graphing it. You do have to put this on here. We're going to do open circles because there is no equal to, and we want positive, so we want going to the left, and we want open circle going to the right. Now I have to state my solution. Negative infinity to -6, not including, union, -1, positive infinity, not including. All right, next one. This one, we got a factor. And by the way, on test day, this is not going to be here. This is not going to be here. That hint down there is not going to be there. You just have to know, oh yeah, I have to factor. I'll do the denominator for you, x minus 2 less than 0. Bing, ding, ding, ding. Let's see. X multiplied to -28, 4 times 7. And we want it to be positive 3, so we'll make the 7 positive, we'll make that negative. So my three critical values are x equals 4, x equals negative 7, and x equals 2. And I'm looking for negative. So we're going to have 4 zones. We have 3 numbers, so we're going to have 4 zones. So let's see, negative 7. 4 would be over here. Well, 2 would be next, and then 4 would be next. Something like that. All right, so we got 4 zones. We've got this zone to the left. We got in between. We got in between, and we got going to the right. Now, just for fun, I'm going to plug in 0 and see what happens. 0, if I plug in a 0 here, 0, 0, and 0, this is negative, this is positive, and this is negative. 2 negatives make a positive. So because the numerator is negative and the denominator is negative, that's positive. So I'm going to take a guess. I'm going to take a guess. This is positive, this is negative, this is positive, and this is negative. Not sure if I'm 100% correct, but I'm going to go verify it on the graphing calculator. Oh, I forgot the red X. Oh, I don't just do this with my mouse. Red X. I don't like having other people's stuff in there. It just bothers me. So, control division. That's maybe the control freak in me. Other people's stuff could mess me up. X squared plus 3x minus 28 all over x minus 2. X minus 2. Enter. Woo. Woo. I can't see nothing. What's going on here? It looks like it's just going forever and ever positive. So let's see here. All right. So at negative 7, it was negative, 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 negative. After that, it's positive, 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 until I get to, it looks like maybe 2. I really don't like this. Let's do this. 50. That's fine. Negative 50. And that's fine. So there we go. I can see a better look at it now. And I want to type in tab. I'm going to type in 2 because it looks like x equals 2 is one of my problems. Maybe I'll type them all in. X equals 2. But that clearly is an asymptote. That was one of my numbers. And my other number was tab x equals negative 7. That's another cutoff number. And then my other one was tab x equals, what's that other one? What was the other variable? 4. So those are my 3 critical numbers that I came up with. Those break it up into my zones. And if I look to the left here, it's negative. If I look in between, it's positive. If I look in between these two, it's negative. And if I look to the right, it's positive. Okay, so come back. And what did we want? We wanted negative. So we want these areas right here. We want this area and, oops, screwed these up, right? Look at that, messed those up. This is negative. I should have gone back and forth. Hold on, let's make sure. To the left is negative, between 2 and 4 is negative. Oh, okay, so I did screw those up. Woo, glad I checked. I actually didn't mean to do that on purpose either. So, open circle, negative, and in between here, open circle, open circle. So from negative infinity to negative 7. Stating the answer should be the easy part. You've done all the hard work. You just come back and you state the answer. There it is, my answer. All right, pause it up. I'll be right back. I just ran out of coffee and we have 2 problems left. God help us. All right, kids, let's see how you did. I'm going to fly through these because I just finished my coffee. Now I'm all excited. Factor. Well, we can't factor the numerator. It's just x. The denominator is the difference of perfect squares or difference of 2 squares. Notice we added the equal to. X plus 3 x minus 3. So remember, and I haven't done a problem like this before, but what makes them equal to 0? So x equals 0 is a critical number. X equals 3, critical number. X equals negative 3, critical number. And I'm looking for positive. Excuse me, I'm looking for positive. Let's graph it. It's going to give us 4 zones, negative 3, 0, 3. We got zone 1. We got zone 2. Got zone 3. We got zone 4. I'm just going to test. I'm going to test negative 10. So if I plug in a negative 10, negative 10, negative 10, and negative 10. This is negative. This is negative. This is negative. 3 negatives is negative, so this is negative. I'm guessing negative, positive, negative, positive. Let's check it out on the calculator. Oops. So we'll go to the calculator. We're at x, no. Back in. Control division. X over x squared minus 9. Ka-cham. Whoa! Funky, funky. So right here, and if you want, you can put in your 3 critical numbers. You can't do this unless you have the new operating system. You can't do this. You should have the new operating system. X equals negative 3 because this is really helpful. Tab x equals 0. Enter. And tab x equals 3. So those are your 3 critical values. Those 3 vertical lines are your 3 critical values like I broke mine up into. So clearly to the left, I'm negative. I think I said that. In between negative 3 and 0, I'm above, so I'm positive. After 0, I'm negative. And after 3, I'm positive. So that's exactly what we said. We said we want positive, so we want this area and this area. So the first thing I'm going to do is I always do open circles. I just say later if I want closed. Positive, connect the dots. Now, what would happen if I type in a negative 3 here? If I typed in a negative 3 here or a positive 3 here, the denominator would become 0 and undefined. So although it says equal to 0, although the original problem said greater than or equal to 0, because it is undefined, and again, you can take a look where the asymptotes are, where these asymptotes are, those will be undefined points and they cannot be in your solution. So I would only be able to fill in this dot right here. These two make it undefined, so you can't choose those. So my answer is negative 3 to 0, bracket, union 3 to infinity. So the only difference is what makes the denominator equal to 0. We're going to factor it. X minus 4. The denominator, x plus 1, x minus 1, and we want greater than or equal to 0 again. So our 3 critical numbers are x equals 4, x equals negative 1, x equals positive 1. We'll throw the, and we want positive. We'll throw them on a number line. Negative 4, negative 1, and 1. And while I'm at it, I got equal to 0. I know it's equal to 0, right? So I know I want to put filled in circles because of that, but I can't fill in circles at negative 1, and I can't fill in circles at positive 1, or negative 1 and positive 1. I can't do that. So I might as well just not even bother. I know I'm going to fill this one in because that's okay. The other two, it's not okay. All right, so let's take a look and see what this looks like graphically. And it's x minus 4, control division, x minus 4 over x squared minus 1, x squared minus 1, enter. And because I want to put my 3 critical numbers in, my 3 critical numbers are tab, let's see, tab, get rid of, going to 6, x equals negative 4, no, it's positive, it's negative 1, tab, x equals 1, tab, and x equals 4, tab. Oops. 4. So those are my 3 critical values. So what's going on to the left of negative 1? To the left of negative 1, it's negative. In between here and here, so the left of negative 1, oh, I have the critical numbers on there wrong. Let's go back. Hey, I'm glad I did that. See, so using your graphing tool oftentimes will shadow some or really highlight some mistakes you might have made. And we'll go to 4 here. So we're going to do a closed circle here. Open and open. So to the left of negative 1, we were negative. So this is negative. Something happened. Control Z, Control Z. There we go. So in this zone, I was negative. In this zone, between negative 1 and 1, I'm up here, so I'm positive. In this zone, I am down here, so I'm negative. And to the right here, I am positive. So I want positive, so I want going this way. And I want positive in between these two. So my final answer for this would be parenthesis, negative 1, 1, parenthesis, union, bracket 4 to infinity. That's it, kids. That's all she wrote. Hit the subscribe button. Hit the like button. Tell me what you like. Tell me what you don't like. I know my voice sounded like I was, I don't know, not even awake yet. But I am now. All right, kids. Hope you all enjoyed yourselves. Have a great, great rest of the year. Keep working hard. And remember this one fact. It is going to be very difficult to get a good job someday. Keep working hard. Shine above your peers.